Now, so let me start with another Green's theorem problem. See here. Let me read the question first. Verify Green's theorem in the xy plane where C is the region bounded by x is equal to 0, y is equal to 0 and x plus y is equal to 1 for integral 3x square minus 8y square dx plus 4y minus 6xy dy. So now we have to verify the Green's theorem. That means we have to find the LHS of Green's theorem and we have to find RHS of Green's theorem. Then we have to get the same values and then we can say the Green's theorem is verified for the given problem. Okay. Now let me write the Green's theorem statement first. Okay. Okay. Now so I am writing this Green's equation or Green's statement in the yellow ink because since it is very important. The formula, it is a formula. Now Green's theorem states that integral over the closed loop u dx plus v dy. Integral over the closed loop u dx plus v dy is equal to double integral over the region R dou v by dou x minus dou u by dou y, dou v by dou x minus dou u by dou y dx dy, dx dy, dx dy. Now first write the given equation, then we have to find LHS value. Okay, yeah, given integral 3x square minus 8y square dx plus 4y minus 6xy dy. Here itself we can write this as u value and this thing as v value, but no need here. First write the limits. The limits are x is equal to 0 and y is equal to 0 and x plus y is equal to 1 and x plus y is equal to 1. Now we have to write the diagram compulsory because we have to show the whomever it say, we have to show the diagram as a closed figure. Unless otherwise, if we cannot show the diagram as a closed figure, we cannot forward the problem, right? See here, first of all draw the coordinate axis and fine. See here, x is equal to 0 means y axis, so it is x is equal to 0 and y is equal to 0 means x axis, it is y is equal to 0 and x plus y is equal to 1, x plus y is equal to 1, x plus y is equal to 1 is a straight line, x plus y is equal to 1 is a straight line. Now we have to find where it is meeting the x-axis and where it is meeting the y-axis, where it is meeting the x-axis and where it is meeting the y-axis. For this thing, I already told you a technique how to find the x-intercept and how to find the y-intercept. See here, x plus y is equal to 0, sorry 1 is equal to 1. Now if we have to find the x-intercept, we have to put y is equal to 0. That means x plus 0 is equal to 1, x is equal to 1. That means the point will be here 1, 0. And similarly, if we have to find y-intercept, put x is equal to 0. So 0, 0, 1, 0 and 0, 1. Okay. Now, yeah. Write LHS. Now we have to find LHS. What is LHS saying? Integral over the closed loop 3x square minus 8y square dx plus 4y minus 6xy dy is equal to, now we have to find the integral over the closed loop. That means we have to complete the figure. That means we have to find the integral over the region. Let me name these points O, A, B. We have to find the limits over OA, and we have to find the integral over the limits AB, and we have to find the integral over the limits BO, over the limits BO. OA, AB, and BO. OA, AB, and BO. Now, along OA. Now, along OA. Along OA. Now, whenever we are doing along OA or something along any line, we have to write the equation of that line. Now, what is the equation of line OA? OA is x-axis. That means y is equal to 0. Y is equal to 0. Y is equal to mean by default dy will be also be 0. Now replace that in the question. What is question here? 3x square minus 8y square dx. Right here. 3x square minus 8y square dx plus 4y minus 6xy dy. 4y minus 6xy dy. Now since we already got y as 0 and dy as 0, if we put here dy will be 0, that means the entire part will be 0. So eliminate this thing, and this remaining part we can find, we can put if you put y is equal to 0, this thing will be eliminated. So the remaining part will be 3x square dx. Kindly be careful while substituting the limits. So here we got already y is equal to 0 and dy is equal to 0. If we put dy is equal to 0, the entire function is multiplying with dy, so it will become 0. And in the first part, y is equal to 0 means this thing will be 0, and what is remained is 3x square dx. Now if you put 3 in the outside, since it is multiplying constant, so we'll get x square dx. Since the function is in x, means dx is there, so function is in x, we have to write the limits of x. See here now, OA. In the line OA, the limits of x are varying from 0 to, the limit of x here is 1. So 0 to 1. So I can write 0 to 1. So 3 into, what is integral x square? It will be x cube by 3. Over the limit 0 to 1. Over the limit 0 to 1. 3 gets cancelled. So the answer will be 1 cube minus 0 cube. And the answer is 1. And the answer is 1. So along OA line, we got the answer as 1. Now similarly, we have to find the integral over the limit over the line AB. Over the line AB. Now right here, along the line AB. Along the line AB. Along the line AB. See here, AB. AB is a line equation. Now, what is the line equation of AB? X plus y is equal to 1. Very good. So x plus y is equal to 1 is the line equation of AB. Now when we integrate, now see here, let me check. Yeah, now see here, now when we differentiate with respect to dx or dy, so it will become dx, it will become dy, it will become 0. That means dx plus dy is equal to 0. Means if you derivate the entire equation, it will become dx, it will become dy, it will become 0. That means dx will be equal to minus dy, dx will be equal to minus dy, dx will be equal to minus dy. I am repeating once again. Here we are finding the integral over the line along the line AB, and the line equation of AB is x plus y is equal to 1. Now you can directly derivate on both sides like this, or you can convert like this. So y is equal to 1 minus x, dy is equal to, so when we integrate, when we differentiate 1, it will be 0, and when we differentiate with x, it will become dx. So anyway we will get same, dy is equal to minus dx or dx is equal to minus dy. Now it is our responsibility to maintain the entire function in a single variable. So what I am telling, I will show here. Now write the question. The question is integral 3x square minus 8y square dx plus 4y minus 6xy, 4y minus 6xy dy, 4y minus 6xy dy. Now since we already got the equation of y in terms of x. Okay, yeah. Yeah. See here, we already got the y value in terms of x and dy value in terms of x. So convert the entire equation in terms of x so that it will be easy to integrate. Since integration is possible with respect to dx or dy only one variable at a time, so we have to convert the respective function in terms of x. Now see here, 3x square minus 8 into, in place of y we have to put y 1 minus x, so 1 minus x whole square dx plus 4 y value is 1 minus x minus 6x y value is 1 minus x and dy value is minus dx, dy value is minus dx. Right here, integral 3x square minus, now so we have to solve carefully. So 3x square minus 8 into 1 minus x whole square means a minus b whole square, it is a square minus 2ab plus b square. I'm not explaining the entire thing. Dx plus into minus will become minus, so write it here, minus 4 into 1 4 minus 4x minus 6x into 1 minus 6x minus 6x into minus x, it will become plus 6x square again with respect to dx. Since it is also with respect to dx, it is also with respect to dx, we can combine and write it as a single equation. Solve it. So 3x square minus 8x square plus 16x minus 8 and again minus 4 minus into minus plus 4x minus into minus plus 6x plus into minus minus 6x square. Entire thing we have to integrate with respect to dx, with respect to dx. Now see here, here it is 3x square minus 8x square minus 6x square, 3 minus 8 minus 5 minus 5 minus 6 minus 11x square minus 11x square and 16x 4x 6x, 16x plus 4x is 20x, 20x plus 6x is 26x and remaining thing is minus 8 minus 4 minus 12, yeah, only minus 12 is remain, minus 12 dx. Yeah, see here we have to write the limits of x. Since the function is in dx, we have to write the limits of x. Now how to find the limits of x? Very simple. See here, here the limit of x is 1, here the limit of x is 0. That means the limits of x are varying from 1 to 0, 1 to 0. Be careful while solving the limits 1 to 0. Now very neatly and very carefully solve the entire integral part. See here, 0 to 1 minus 11x square plus 26x minus 12 plus 26x minus 12, entire thing under dx. Now we have to split, integral minus 11x square plus integral 26x minus integral 12, all with respect to dx. Now see here, minus 11 into integral x square dx plus 26 into integral x dx minus 12 into integral 1 dx. Now see here, minus 11 into integral x square will be x cube by 3 over the limit 0 to 1 plus 26 into integral x will be x square by 2 over the limit 0 to 1 minus 12 integral x over the limit 0 to 1. Now if you solve it, it will be minus 11 by 3 into 1 plus 2 1s are 2 13s are, so 13 into 1 square is 1 minus 12 into 1 is 1, so 13 minus 12 is 1, so minus 11 by 3 plus 1 It'll become 3 1 3 minus 11 plus 3 minus 8 by 3 minus 8 by 3. Okay. Now see here. Now we got minus 8 by 3. But let me check here. Here the limits are varying from 1 to 0. Here the limits are varying from 1 to 0. But what we have written, it as 0 to 1. So no need to worry. We have to just put the minus symbol for this thing. So the answer will be minus of minus 8 by 3. It will be 8 by 3. See, this property we have studied in class 12. Integral a to b f of x can be written as minus integral b to a f of x dx. Okay, so that means, remember my students, if you wrote the limits reversely, okay, no need to panic. You just have to put minus symbol for the answer. That's it. Okay, so anyway you will be getting the same answer, but no need to panic. See here the limits are varying from 1 to 0, but what we have wrote mistakenly, it has 0 to 1, but no need to panic. So limits are same, 0 and 1, but we have changed the order. What we have to do, we have to put the minus symbol for the last answer or entire thing we have to put. So the answer is here 8 by 3. Now, so we have founded the limits. I mean, we have founded the answer of the integration part for the line OA and the line AB, and the last remaining part is along the line BO, So let me separate it here, or no need. So I'll write in the next slide. It'll be good for seeing. Along the line BA. Now, before integrating, we have to write the equation of BA. So that is very important. So every time I'm telling you that thing. Whether if we are doing integration, but before doing integration, we have to write the equation of that respective line. So here, it is BO. What is BO line? BO is y-axis. Y-axis means x is equal to 0. That we have to write. BO, it is okay. BO. Okay. Y-axis means x is equal to 0. X is equal to 0 means dx will be 0. Dx will be 0. Now, we have to write integration. 3x square minus 8y square. Right here. Integral 3x square minus 8y square dx plus 4y minus 6xy dy. 4y minus 6xy dy. 4y minus 6xy dy along the line BO. See, already we got the equation of line BO. It is as x is equal to 0, and also we got dx is equal to 0. Since dx is equal to 0, the entire thing will be 0. So when 0 is multiplied with anything, so the entire part will be 0, and this thing is eliminated. Okay, and the remaining part also, when we substitute x is equal to 0 here, this part will be eliminated. So at last the remaining part is 4y into dy. Now clearly observe, the function is in y. Since dy is the only part available here, the function is in y. Now what we have to write? We have to write the limits of y. That is very important. Whatever the function is remained, we have to write limits of the variable. Here dy is remained, so we have to write limits of y. So what is limits of y? From B to O. So this point is 1, 0, 1. So y is varying from 1 to 0. Write carefully, so don't do mistake again. 1 to 0. So 1 to 0. Okay, we have to write the first limit as lower limit and second limit as the upper limit. 1 to 0. Now, since 4 is a constant, we can write outside, and 4 into integral y dy. So what is integral y? Integral y is y square by 2. Y square by 2, that means 1 to 0. Okay, so that means 2 1s are 2 2s are. So 2 into upper limit 0 square minus lower limit 1 square. So it will be 2 into 0 minus 1. That will be minus 2. So overall the integral part can be represented as sum of along OA line and along AB line and along the BO line. So along OA line, the answer is what we got here, 1, and second is 8 by 3. See here, along OA line we got 1, and along AB line we got 8 by 3. So 1 plus 8 by 3 minus 2. 1 plus 8 by 3 minus 2 along BO line. So when we solve it carefully, 8 by 3 plus 1 minus 2 is minus 1. So 3 ones are 3. It will become 8 minus 3 by 3. That is 5 by 3. That is 5 by 3. It is the LHS value. I am writing, I am putting it as equation 1, Roman number 1. Okay, now we have to verify the Green's theorem RHS value. Now first write the formula of RHS only. What is RHS formula? Double integral over the region dou v by dou x minus dou u by dou y, dou v by dou x minus dou u by dou y, dx dy, and we have to find what is u value and find what is v value. Since clearly it is given, I already told you right while writing the equation, the part which is before the dx is known as u and the other part is known as v. So write that thing. U is equal to 3x square minus 8y square. Here u is equal to 3x square minus 8y square. 3x square minus 8y square, and v is equal to, right, v value, 4y minus 6xy. 4y minus 6xy. 4y minus 6xy. So it is u value, it is e value. Now what we have to find? We have to find dou v by dou x and we have to find dou u by dou y. See here, dou u by dou y means we have to derivate dou by dou y of u. That means dou by dou y of 3x square minus 8y square. So when we are derivating with respect to y, x is a constant. So remember that thing, and it will become 0 minus 8 into, so y square with respect to dy, it will become 2y. So the answer will be minus 16y, and we have to find dou v by dou x. That means we have to derivate with respect to x, dou by dou x of v, dou by dou x of 4y minus 6xy, 4y minus 6xy. So dou by dou x of so no need to write again. So when we differentiate y with respect to x, it will become 0 and minus 6 into, so when we differentiate x with respect to x, it will become 1, and since y is a multiplying constant, we'll write as it is. So the answer is minus 6y. The answer is minus 6y. Now substitute them in the respective values. So double integral dou v by dou x, dou v by dou x, dou v by dou x means minus 6y. See here, dou v by dou x means minus 6y, and dou u by dou y means minus 16y. So minus 6y minus of minus 16y. Be careful, dou v by dou x value is minus 6y, and we have to put minus symbol as it is. Then we have to look for dou u by dou y. So dou u by dou y is minus 16y. So overall we'll get limits in the dx dy. So that means double integral minus 6y plus 16y, it will become 10y dx dy, 10y dx dy. Now the most important thing is what are the limits? What are the limits? Right. Since the first function is in dx, we have to write x limits, and the later function is in y, we have to write y limits. I'm telling you once again, the outermost part is y. That means y limit should be constant. Y limit should be constant. As we already know, y limits are varying from 0 to 1. Y limits are varying from 0 to 1. Okay, we can write it. No need to hassle. 0 to 1. But while writing x limits, we have to write in terms of other variable. While writing x limit, we have to write in terms of other variable. So the x limits are varying from 0, and for the upper limit of x, we have to solve. See here, x plus y is equal to 1. So x is equal to 1 minus y. X is equal to 1 minus y. I already told you that the outermost limit, the outermost integral should have constant limits, and the inner integral should have the limits in terms of other variable. See here, the inner limit is x. That means we have to integrate first with respect to dx. So we have to write the x limits first. That means in terms of other variable, and the outer integral, we can write the limits as outer integral as constant. So y limits are varying from 0 to 1, and x limits are varying from 0 to 1 minus y. Now see here, consider the inner part. Integral 10y dx, where x is equal to varying from 0 to 1 minus y. I am telling you once again, the integral part inside when we have double integration, the integral part which is inside should contain the limits in terms of other variable. Since the inside function is here x, we have to write the x limits in terms of y, x limit in terms of y. So that is what I have written here. Now here, see here, integral 10y. So 10 into what is integral y? Y square by 2 over the limits 0 to 1 minus y. So 2 1s are 2 5s are. I'm sorry here, sorry. Since we have to integrate with respect to x, na. So how can it become y square by 2? See here. Yeah, no. See here. So both 10 and y are constants since we are integrating with respect to dx. So 10y into integral 1 dx. Okay, so 10y into x integral 1 dx is x. Be careful, we are integrating with respect to dx here. So both 10 and y are constants. Okay, be careful. Okay, now limits are varying from 0 to 1 minus y. So that means it will become 10y into x. In place of x we have to put the upper limit first and then we have to put lower limit. So it will become 10y into 1 minus y. Now if you solve it carefully, it will become 10y into 1, 10y minus 10y into y, 10y square, and we have to put in the integral value. I mean, we have to put in the integral value. So the answer for innermost integral is found out, and now we have to replace here since we have double integration, na? So 0 to 1, 0 to 1. So what is the value here? 10y minus 10y square to put here. 10y minus 10y square with respect to dy, Now it is very simple. See here, 10 into what is integration of y with respect to dy? It is y square by 2 minus 10 into integral y with respect to integral y square with respect to dy, it will be y cube by 3 or the limit 0 to 1. That means 2 1s are 2 5s are. So 5 into upper limit minus lower limit minus 10 by 3 into upper limit minus lower limit. So 5 into 1 5 minus 10 by 3. So 3 5 are 15. 15 minus 10 by 3. So that is equal to 5 by 3. That is equal to 5 by 3, which is RHS value equation 2. And already we got LHS value as 5 by 3. So now both all LHS and RHS value are equal. So now we can say that Green's theorem is verified. Green's theorem is verified for the given question, right? Okay, I'm glancing you once again the entire problem since it is somewhat different from the first problem. See here, whatever may be the problem, first you have to write the Green's theorem statement and underline it as a box. Something else you have to write, since this will provide the examiner some confidence that you know the Green's theorem basic statement. Okay, you will be given some marks, you will be awarded some marks particularly for the Green's theorem statement. So write that. So what is Green's theorem statement? Integral over the closed loop u dx plus v dy is equal to double integral over the region dou v by dou x minus dou u by dou y dx dy. Now then you have to write the given equation. What is given equation? Given function 3x square minus 8y square dx plus 4y minus 6xy dy, and then you have to write the limits, and correspondingly you have to draw the diagram. Particularly diagram is very important because Green's theorem mainly stands on the lines in a closed loop. That means unless otherwise if you draw the diagram itself, you cannot find the limits. Okay, so you have to find the you have to draw the diagram from the given limits. See here, x is equal to 0 means y axis, y is equal to 0 means x axis, and x plus y is equal to 1 is a line lying on the coordinate axis. Now you have to follow the loop. You have to follow the loop along OA and along AB and along BO. See here, along OA, y is equal to 0, dy is equal to 0, and you know the integration part pretty easily. And along line AB, this is very important. Since the line AB equation is x plus y is equal to 1, it contains both x and y, but it is our choice that we have to write in a single variable. So here I wrote this in the y value in terms of x. I wrote the entire y value in terms of x, and dy is all dy also in terms of dx. So what I did here is enter replace dy terms with the dx and y terms with the 1 minus x. So and after that I did integration and I got values. Okay, and similarly along line bo I got that, and after summing up all these three terms, the final answer I got is 5 by 3, and RHS also I got the same value. RHS also I got the same value. Okay, so 5 by 3. Okay, so now LH is RHS and they must be equal, then only we can say the Green's theorem is verified, right? Okay, please like, share and subscribe to next programming world. For more videos, please keep on watching the channel. Okay, these are the toughest problems, and uh, I'm pretty sure that these things are very important for you, not only for mathematics and machine learning also. So I'll be a mentor for you. I'll be a guide for you for your entire journey, and these tough problems will be explained in a very hassle-free manner. Okay, please like, share, and subscribe to Nike Programming World. Thank you.